Hi everybody, it's Mr. B from Hayfield Secondary School, and this is the first video in a sequence of videos for the balsa bridge project. That is part of the structures unit, the civil engineering unit for engineering 2. We're going to talk about, we're going to get started with the design on it and what the specifications are for the bridge, and you're going to need your Pisco Bridge book. You're definitely going to need this, and you're going to need a pencil and a ruler, okay? So make sure you have those available to you. Remember, at any point, if you need to go off and do something, like get these materials, just pause the video, come back and start it again. Okay, the prerequisite for this video is you have seen the presentation, the structures presentation on the balsa bridge and balsa tower projects. It's a lot of information that you need to have absorbed from that presentation before you're ready to start your design, okay? If you haven't done that, go get that presentation. It's in the classroom website, okay? So we're gonna go ahead and move forward. I'm gonna be pointing my camera down at the Pisco Bridge book because tons of the information that we're gonna be talking about is in this book. All right, so here we go. All right, I'm going to flip it around for you. First of all, I want you to notice, and I want you to go ahead and write this in your book if you haven't already done so. I want the width of the bridge for this project is going to be 10 inches. So you're going to write 10 inches. The double quote is the symbol for inches. A standard symbol for inches. So 10 inches is the overall width of the bridge. You're going to do a 3-inch maximum height. So I actually drew this line here and then drew 3 inches, double quote, max, to show that that is the maximum height. What do I mean by maximum? You can make the bridge shorter than 3 inches if you wish. You cannot make it any taller than 3 inches. So your bridge will be 10 inches by 3 inches. And for this project, because of our time constraints, we are not doing the substructure. So you can X that out. Pay no attention to the substructure anywhere you see it going forward in this book. We're only working on the superstructure. The superstructure is the top part, and the substructure is the part that's below the bridge, okay? So make sure you make those corrections or additions. All right, there is some really good information that you should be looking at before you dive into your design, and that is this book. It's a good piece of material here. Talks about the different forces that there are on a bridge and things that you want to take into account. This is a great example of showing how you take a rectangular shape without any diagonal supports on it, and it is prone to what we call racking. So if there are forces put on this rectangular shape and there is no diagonal support, the rectangle can easily deform. But if you put a diagonal support in it, it will not deform because the diagonal part will actually help distribute the force and maintain the integrity of the rectangle. These bridges are truss designs. You notice all of these triangles, and the addition of the triangles should not be overlooked. Triangles add a lot to strength to the structure, as well as they prevent what we call racking or deforming of the original shape. And you notice all the designs that you see in here, the example designs, have that characteristic triangular shapes throughout the design, which we call a truss design. You see it with all of these examples. Triangles, the strongest geometric shape. Okay, down here they're talking about various possibilities. I've already told you that our bridge length is going to be limited to 10 inches and the height is going to be limited to 3 inches. And we noted that right here on the first page. You had to write that in. All right? Again, pay no attention to the substructure. We're not doing the substructure because we are constrained by time. This is just some different drawings of some very, very simple truss designs up to slightly more complex. Again, that triangular shape is characteristic, and it is just showing you, you see these areas here, they actually call them bridge support system. It's really, these are called abutments. This is what the bridge sits on. So imagine the area in between is we call the span of the bridge. That's the greatest distance that the bridge can go from one side to the other with enough of the bridge on the abutment for support. So this could be a river, a valley, could be a roadway down here. That's considered the span. So since we need to have each one of these abutments is going to be 1 inch, okay? We're going to use the 1 inch minimum. It's listed right here. So 1 inch on each end for the abutments, or bridge support, they call it here. That means our maximum span will be 10 inches. I'm sorry, 8 inches. Because our bridge, our total length of the bridge is 10, but you take away 1 inch for the abutment on each end, 10 minus 2 obviously is 8. So our span will be 8 right here. So you can just scratch out the 18. It's going to be 8. All right? We can now jump over here to page 3, where the design process begins. Now, these are what we would call thumbnail sketches. So these are sketches that are drawn quickly by hand. They're not meant to be architecturally perfect with dimensions or shape. You are just trying to express an idea and doing a relatively quick sketch to do it. You may or may not choose to use your ruler when you do it, and you're not worried about it being perfect. It's just some quick sketches. If you refer back to the structures slide presentation, there's one page in the bridges section that shows about, I think it's about 12 or 16 different characteristic truss bridge designs. That is where you should be getting your ideas. There's the Pratt truss, there's the Warren truss, there's the Philadelphia, et cetera, et cetera. Lots of different truss designs. You would get your ideas from there. There's one called the Camelback. I think the Camelback is kind of cool because it's kind of an arch, and you can use this grid paper here to kind of help you with your design. And again, you can see I'm really not trying to make it perfect, but basically a Camelback looks something like this. And you see I'm just freehanding it. And then the Camelback might be supported by a truss design, something like this. Again, use your own ideas. Don't copy mine. I'm not promising you that this is a good design or a bad design. It's just a design. And you can see it's a sketch. It's not drawn very accurately at all, but it's an idea. So it's something that I could sit down with somebody else and have a conversation and say, what do you think about this design? Okay, so it has to be drawn a little accurately, but that's good enough, all right? And so I can have a conversation with somebody, go, well, maybe I think you need to add some more supports here or there or wherever. And then I could just say, okay, so I could add those supports after a conversation with somebody else, probably being your teacher. And they would go, oh, okay, yeah, I think that's better, all right? You see how easy we were able to do that? Well, then let's say do another design. One of the classics is just a rectangle design. There's actually a really cool truss bridge if you go down Route 1, right near Lorton, where it goes over the Occoquan River. There's a train truss bridge. It's really cool. It's really old too. And so this is a classic design. Very simple. There's definitely no rocket science in here. And looks like I kind of miscounted at the end, but that's okay. That's why somebody looked at that and go, oh yeah, I can see you're going to do a very, very classic truss design, etc. You get the idea. So you want to be doing 2 or 3 of these, and then have a conversation and evaluate, okay, what is it that, what design am I going to go with? I can't build all of them. I'm going to go with one. And so this gets in, so that's your design. And they actually gave you space to do 1, 2, 3, 4, 5 different prototypes, if you will, thumbnail sketches. This I did too. I'm torn between the Camelback and this classic design. And again, if you look at the presentation, there are a whole bunch of them in there. And yes, it is not drawn. You can see it's kind of sloping down and all that good stuff, all right? So you get the idea. Read the rest of this. It talks about how you want to be building your design. It gives you good tips on how you should be putting your joints together. There are miter joints, there are butt joints. You are going to be sticking with miter joints and butt joints. You're not going to get into any of these fancier mortise joints. That's where you kind of cut into one piece of wood and they fit inside of each other. Very complex, takes a lot of time, very strong. But this is not appropriate for the materials we're using. We're using 1/8" basswood, not balsa wood. I know the project says it's a balsa bridge, but actually I gave you basswood for the bridge. Basswood is much stronger than balsa wood. Okay, so let's say I picked a design. I'm going to go with just a very classic truss design. It kind of looks like a Warren, but don't hold me to that. This is just for demonstration purposes. So now I'm going to take my big piece of graph paper. This came in your kit as well. Now I need to draw the design I intend on doing. That's this one, and I need to draw it accurately. Okay? I can't be messy anymore, because whatever we draw, we're going to build right on top of it. Just like I'm reaching for an example. Now this is actually for a tower, but it is exactly the same technique. So whatever you draw on the wood, you're going to put the wood right on top of that drawing and glue it down in place. So your graph paper will be on your project board. We will cover it with wax paper so that when the glue dries, this will come off the wax paper easily. But now we have to draw it very accurately. So I do have a little fold in here. That's from getting it in and out of your folder. And it's a really nice fit on our project board. I'm going to go ahead actually and kind of tape it in place so it doesn't wiggle around on me all the time. But if you want to work on your desk, if you have room for it, I think because we're doing virtual learning, a lot of people are having desk space constraints. All right. Now I'm going to draw my my bridge. Now, remember our bridge from the very first page is going to be a maximum, well, it's going to be 10 inches and a maximum of 3. So I need to get at least I need to get a 10 by 3 rectangle on here. And this graph paper is super helpful. So let me get a pencil, it's a little sharper. Here we go. So I'm going to draw a rectangle up at the top here, and I'm going to make it 10 by 3. Because that works for me. So 3 inches. And then I'm going to go down 10 inches and use the graph paper as a guide. Helps you draw straight lines a lot better. So oops, I'm sorry. So right there is basically 0 on this ruler. I'm going to go out 10 inches. Now you're probably surprised that I decided to use inches instead of metric, millimeters and centimeters, because you know what a big fan I am of that. But this book was all full of inches, and so I didn't want to have to rewrite the whole book. Don't have time for that. I'm going to do this end. I'm going to go up 3 inches. Let's see here. Put my pencil where I wanted to start. With the graph paper, help me draw a straight line. And then the top of the rectangle. So why am I, sometimes it helps to turn it around too. Helps you see what you're doing. Little tip on drawing. Put your pencil where you want your line to start. Hold it there, bring the ruler up to the pencil, and now all you have to do is worry about the other end of the ruler and lining that up. It makes lining up both ends of the ruler pretty easy. Oops. And don't let your ruler move around. You've got to press down on it a little bit harder than I just was. Okay, so there is a 10 by 3 rectangle. And now I can do my design. Well, if I'm going to do, this is where you kind of got to start thinking and be smart. You don't want to have to be doing a lot of erasing. If I'm just going to do a simple crisscross design like that, very simple truss design, I want to make sure that it's symmetric. Symmetric on the right and the left. So I need to evenly space these X's. And so since I have 10 inches, what's a nice multiple of 10 is like 2. Now 5 would be too big, and I don't want to do 3 because then it's really 10 inches divided by 3 and into 3 rectangles is, 3.33 inches, and how the heck do you measure that? If we're using millimeters, wouldn't be a problem. But so here's what I'm going to do. I'm going to make each one of my sections on here 2 inches, because 10, which it has to be 10, is easily divided by 2 into 5 sections. I'm just finding the midpoint, so I measured here, 10 inches, here's 5, I found the midpoint, and now I am just going to do, for my midpoint, I'm going to do here, 2 inches. So 1 inch on either side. I'm going to make these marks dark. My first 2-inch section. So then it's 6 and then it's 8. 10 right there. And another 2-inch. Okay. I've actually decided to put vertical supports in these areas right here. I just thought of that. Vertical supports combined with the triangular supports would be nice and strong and very easy to draw. Again, this is my design. Whatever your design is, your design. You can copy this one, or you can do your own, okay? And I'm just doing a very, very standard design, very simple. It's just a bunch of X's. But you do want to think about this before you start drawing. You want to do something that's going to be relatively easy to draw. And notice I put my pencil where I want the line to start first, slide the ruler up to it, then I only have to adjust the other end of the ruler. You can move very quickly like this. Because trying to line up both ends of a ruler like this at the same time, you move one end and it moves the other end, real pain. Put your pencil down, slide the ruler up to it, then you just have one end to adjust. You can do that really fast. So if you're timing me, you're going to find that I get this guy completely designed in, I don't know, and I'm talking a lot too, so what's new with that, right? That's what teachers do, we talk a lot. And there we go, I'm done, all right? So all I need to do is I need to do that again. I need two of these because bridges have two sides, okay? I need two of these. So I am going to stop the video here. I don't find it very productive to record a video showing me do this, the exact same thing again right here. I'm going to do this and then I'm going to do it again, all right? And that's where the next video will pick up after I have both of these done, okay? So, I hope that was helpful for you. This is the end of the video. We'll start the other video where I will have my design done. I will have two of these because bridges have two sides, all right? And we'll pick it up from there where we're gonna cover up the drawing with wax paper, and then we're actually gonna start building the frame and the interior triangle web, okay? So, wow, this got crooked. How did that happen? All right, so this is where the video will end, and good luck, and I'll see you in the next video.